So hello everyone, welcome back to the channel. I hope you are guys are doing amazing. So let's start with the daily challenge of Leetcode today. We have this domino and tromino tiling problem. So we have two types of domino, a 2 cross 1 domino shape and this tromino, and given an integer n, we have a 2 cross n grid. We need to fill this grid with dominoes and trominos and return the answer modulo 1 plus 7. So you can see that in this tiling every square must be covered by a tile. So for n equal to 3 the value is given. There are 5 such possibilities. So looking at this problem, you can first try to analyze what will be the answer for n equal to 1. So for n equal to 1 we have just one possibility. For n equal to 2 we have two possibilities. We can place two horizontal and two vertical, and for n equal to 3 you can just put it in this way as shown. So three base cases you can easily clear from this. You can easily just code it out that it should be n for n equal to 1, n equal to 2 and 3. But you should also try to see that there can be some recurrence relation between n and n minus 1 or n and n minus 2 and minus 3 in terms of those. So this could be a potential DP problem if you could find out the recurrence relation. So let us see how to just approach this. So let's say we want to fill this entire domino till I. What can we do is that we can first fill it till I minus 1, as we try to think this thinking pattern for any type of DP if we are directly trying to write the tabulation method. So for I minus 1 what we can do is place one domino here, one cross 2 domino here. So how many, if I define a function fi, you can easily see that there has to be some term of fi minus 1. There is only one way from I minus 1 we can reach fi. Let's talk about fi minus 2. If we have filled till I minus 2, it is easy to think that we would have a 2 cross 2 square left, which we can fill it in this way and also in this way. But if you try to think clearly, if you fill it in this way, then you are just overlapping the case which you have already taken for I minus 1, because this is the I minus 1 portion and you have already taken into that into account. So for the I minus 2th case, you only have one choice to fill the two 2 cross 1 dominoes in this manner. So fi should also have one term of fi minus 2. It should be very clear by this. Fi should also have one term of fi minus 2. Now if you try to think of what could be some other ways, it is very tempting to think of the case of I minus 3, but that is a tricky part. So let's try to visualize. If we try to think that something like this is that I minus 3 and then we have a 3 cross 2 grid, and you might tell that I'm trying to fill it in this way and the other way around. So we have two possibilities, and hence 2 into fi minus 3 term will also come. But this is wrong. If you try to visualize why this is wrong, because if you are neglecting these cases, these trominos is a tricky case, right? It can also be filled in this way. You are missing out this portion. If you just take account, if you are trying to just add this term, so you are missing out this portion. So we need to be very sharp with our approach. Yeah. So let's take this case and let's say this is I minus 1 and we need to fill this with this tromino. There is only one choice. So what you can say that this is a bottom missing portion. This recurrence relation cannot be called as f. Let's call it as b, bottom missing portion of I. So if you have fi, you can easily say that it also contains some term of bottom missing portion of I minus 1. Similarly, there could be some top missing portion, and there is only one choice to fill this top missing portion also. Yeah, so f of I should also have a term of this top missing portion. Is it clear? So if you see we have discussed about the cases here. If you see uh, this case and this case are really identical to each other. They are symmetric cases, right? This is quite easy to visualize, and hence T of I, top missing portion of I, can be said to be equal to the bottom missing portion of I. This has to be clear. Yeah. Now, can you try to find now what you can first think is that the thing which I told earlier, that f of I has some terms of b of I minus 1 and t of I minus 1, but we need to get rid of these terms, right? So what we do here is to write what we have already got. F of I we have already got to be f of I minus 1 plus f of I minus 2 plus t of I minus 1, and another term was there, b of I minus 1. So instead of that I am writing 2 into t of I minus 1. We need to get rid of this 2 into t of I minus 1. So we need to, we can look forward to find some more recurrence relation for this thing. So if this is I, for I minus 2 there is only one choice to fill it with this Tromino. So you can say that T of I is definitely having a term of f of I minus 2. So T of I is definitely having a term of f of I minus 2. You can say easily take it from here, and it you can also visualize it in this way, that it also has a term of, you can just fill it in this one way of this domino. So it also has a term of T of I minus 1, isn't it? So we have got some recurrence relations. Let's try to solve those and see what is the outcome. So I will just try to solve this in the comments. So at first I have f of I equals to f of I minus 1 plus f of I minus 2 plus t of I minus 1, 2 into t of I minus 1. As I told you, the two symmetrical cases, this is the top missing and the bottom missing portions. So I'm directly writing it as 2 into t of I minus 1. Now again I have got the relation of t of I to be, what did I get the relation? T of I to be f of I minus 2 plus t of I minus 1. F of I minus 2 plus t of I minus 1. So I need to replace this t of I minus 1. So if we try to approach this by replacing I by I minus 1 in the second equation, I get f of I minus 3 plus t of I minus 2 in here. And if I replace this equation with in this term, I do get something like f of I equal to f of I minus 1 plus f of I minus 2 plus 2 into f of I minus 3 plus 2 into t of I minus 2. So yeah, we do have this problem of t of I minus 2. So what can we do is that we can try to replace I by I minus 1 in this equation. Then f of I minus 1 would be equal to f of I minus 2 plus f of I minus 3 plus this would be t of I minus 2, 2 into t of I minus 2. And so you would be delighted to see that you can finally cancel the t term by just subtracting these two equations. So by subtracting and transposition, we can easily write it as f of I is 2 into f of I minus 1 plus f of I minus 3. And the remaining terms does get cancelled out. It is easy to see that. So let's just quickly code it out. We define a hash define ll long long, and we try to initialize a vector dp into this. Let's take n minus 1 for safety purpose, and let's write the base cases. If n equal to 1, return 1. Yeah. If n equal to 2, return 2. If n equal to 3, return 5. We have these three base cases, and now we need to fill the dp for int I equal to 3, I less than n, I plus plus. We have dp I equals to 2 dp I minus 1 and plus dp I minus 3. Now we also need to place a mod here as told in the question. So I will define llmd equals 9 plus 7. So you know how to put such mods. You just place mod for both sides and then place an whole mod to the entire bracket. So yeah, you do have this, and you just need to return dp n minus 1. You also need to store the base cases in dp, since this is n minus 1 form of dp. So you just dp0 is 1, dp1 is 1, 2, and dp2 will be 5. dpi denotes result of n minus 1, I minus 1. So that's why for n equal to 1, we have dp0, dp1, dp2, and we just return dpn minus 1. So yeah, that's all I guess. Let's try to run this and see if it works. So yeah, it got accepted. Let's try to submit this. So yeah, we do have the accepted thing. So yeah, that was all from this problem. Though you can call it a medium hard kind of problem for today's daily challenge, but I hope your day would be easy. Thank you so much.